6, 8, 9, 10, 14.
Yeah, that's fine. How about the bottom one?
Okay. Hexagon. Work out the perimeter of the hexagon. So. Perimeter. So this is perimeter, not area. So it's the sides. It's 6 sides. So hold on. Perimeter of the triangle is 24. So it would be 6. It would be 24 times 6.
The perimeter of the triangle is 24.
Right.
How many sides are on the triangle?
3. That's 3 sides. But with the hexagon's got 6 sides.
So each side of the triangle, what size is it?
Oh, so 24 divided by 3, which is 3 times 6. 8.
Yep.
So in that case, it would be 8 times 6.
Yes.
Yeah. Which is 8 times 6. 16. 48.
Yeah. And if you're ever stuck to multiply by 8, you double it 3 times. So double 6.
Double 6 is 12.
Double 12.
24.
And double 24.
48, sure. See.
And and that works because 8 is the same as 2 times 2 times 2.
Right.
Okay, I think you're good there. Okay, top left.
Okay. Square. One side of the square. So, basically for the rectangle, it'll be 8 plus 8, and then 2 plus 2, so that's 16. Plus 4 is 20. So it's saying that it's the same as a square. The perimeter is the same. So I guess it would be 20 divided by 4, which is 5.
That's it. Let's see. How about top right? No, let's do the bottom one.
Okay. So 30. 6 each rectangle work out the length of one side.
No, that's very similar. Let's do top right.
Okay. Okay. How many more squares? 6. So that would just be double. So that would be, so there's 9 in that one, so it would be 80.
So that's what your intuition tells you. My training tells me that won't be it. 1, 2. So that's 6 and 6.
Right. Oh, I see.
So how many squares is that?
Right. So 3 by 3. 3 and 3, that's 9. It's basically 4 times 9, which is 36. 36 squares. Oh, excluding. So 3 times 9. 27.
So yeah, the big one, the area of the big one is 36. The area of the little one is 9. And you find the difference, and it's 27.
Right.
That's it. 27 extra squares. So now that's going into area.
Right.
How would you do the one on the left?
Draw a rectangle. The perimeter of 5 centimeters. So 5 centimeters. So it's going to be. So
the trick for these is to first draw half a rectangle.
Half a rectangle. So half a rectangle will be a square. So
no. So just half of the rectangle. What would be the perimeter for half of the rectangle?
it would be 5.
And so how could you draw that?
So it would be 4 along, 4 down. So 2 down, 2 along, 2 down. God, these really confuse me for some reason.
So it's just a perimeter of 5, and it's half a rectangle.
So if it's 1 square, so it'd be 4, no, 2.
So how many up, how many right to make a perimeter of 5? It's just 2 numbers that will add up to make 5.
Oh, 3 and 2.
So you could say 3 along and 2 up.
Oh.
And that's half the rectangle, and then you just complete it, and it will have a perimeter of 10.
Right, I see.
And so the trick is to do half of it. So same thing. How about this one?
Okay, so 40. So half of 14 is 7. So 5 and 2 make 7. So 2 up, 5 along.
Yeah. And then
you just join it together.
Yeah.
And then you give.
And that's 5, 10, 12, 14.
So, right.
Okay, now we're into area. So top left one.
So that's just going to be 7 times 10, which is 70.
Yeah. Top right.
Top right. Find the area of A. So it's going to be 3 along, 2 down. So that would just be 3 times 2, which is 6.
Yeah, and how about the bottom one? Bottom right.
Bottom right. 5, 7, so we've got 1, 2, 3, 4. So it's 4 along. Oh, okay. So we've got 1, 2, 3, 4, 5, 6, 7, 8. So it's 8 full squares. And then it's 9, 10, 10 and a half.
So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. I'd say it's exactly 10.
Oh, it's 10.
Yeah.
Great.
So maybe if it was in front of you, it'd be on paper. Yeah. You can square it off. Okay, how do we do top left?
Left, draw a rectangle, area 12 centimeters squared. So that would just be 3 up, 4 along.
Great. And top right?
Top right. 1/4. So it's basically without a quarter, so it would be 4 times 6, 24. So basically that'd be 1/4 of 24. No.
Okay, what is 1/4 of 24?
So 24 divided by 4 is 4 times 4 is 16, 4 times 5 is 20, so 6.
Yeah.
Times 1, so yes, 6.
And so how do you know that has it? So that's what he's saying, it has an area of. How do you know that that's true?
So if you add up the squares, it should add up to 6.
How else can you find its area?
Oh, so it's a triangle, so half times base times height.
Yeah. What's the base? What's the height?
So the base is half times 4 is 2. So it'd be 2 times 1, 2, 3, 2 times 3, 6. So it's correct.
Yes. That's 3 and that's 4 is 6. Yeah, therefore he's correct. That's it. How do you do this? Do you know?
Okay. 3 meters. So that's centimeters. It's basically there's 100 centimeters in a meter, so it's 300 centimeters.
It would be if it was meters and centimeters. Instead of it being 3 times 100, because it's meters squared, it's 3 times 100 squared.
Of course. So, so you wouldn't just write 300 centimeters squared.
So you have to actually calculate this, like 3 times 100 squared.
Oh, right, okay. So, so it's 300 times 300, which is 900.
No, just 300 times 100 times 100.
All right. So 3 times 100 is 300. 300 times another 100, so that's 3,000.
Well, let's say 4 zeros.
4 zeros, yeah.
Yeah, centimeters squared. Okay. So if you're converting an area, it's times the scale factor squared. If you're converting a volume, like centimeters cubed, it would be times the scale factor cubed.
Right.
Okay, top left.
Okay. Work out the volume of this cuboid. So basically it's 10 times, like the cross section is 30. Then it's 30 times 4, which is 120.
120. And this one is centimeters cubed. How about bottom left?
Okay, bottom left. Volume of the cuboid is 120. So, so it's 120. Would you volume? So that's the whole shape itself. It's not just the surface.
Well, the base is 5, the length is 8, the volume is 120, and you have to find the height.
Yeah. So to find what the height is, so it's 120. 5.
So how did you do the one above it?
The one above it, it was just width times height times length.
Yeah. So it's basically going to be 5 times 8 times the height. And what will it give you?
120.
And you have to figure out what height will give you that.
Right. So you divide instead, I guess. So it'll be 120 divided by 5. Divided by 8.
Well, yeah, it'll be 120 divided by 5 times 8.
Oh, right. So 5 times 8 is 40. So 120 divided by 40.
What is that?
So if you break that down, so it's 60, 20, and then
and they both end in a 0, so there's something quick you can do.
10. So they're both in a 10 times table. So so 10 times 10 times 12 is 120. 10 times 4 is 140. So 4 and 2. 12. So 6 over 2 can be broken down again. So 3 over 1.
Yep. And what is 3 divided by 1?
3 divided by 1 is is it 3? Just 3.
Yep.
Yep.
And so the height must be 3. And if you do 5 times 8, you get 40. Times 3, you get 120.
Right. Okay.
How about top right?
Okay. Made out cubes. Each cube has edges of length 2. Work out the largest number into the box. So if we work out the area, so or the volume. So it's 2 times 1 is 8. 8 times 6. 8 times 48.
So you could. How many boxes can you fit across?
2.
So you can fit 2 boxes across. How many up?
Just 1.
Yeah. And then how many along?
3.
Yeah. And so what would be that volume?
Right, so that would be 2 times 1 is 2. 2 times 3. 6. 6 boxes.
Yeah, I believe so.
Yeah.
That's it. Yes, and I think the other way will work, but you're going to get some, big numbers. 8 times 3 times 1 equals 6 boxes. Any questions there?
No, it makes sense.
They're working in reverse one. Just write down the things. Okay, how about this?
Okay, just moments to record. To receive. Almost 95 minutes long. Just to yes. So 90 minutes is an hour and a half.
Mm-hmm.
So we're 5 minutes out. Can just record. No, she can't because it's 5 minutes out.
Yeah. Short. Okay. I think you're okay for these. I think you're okay to. Let's just do bottom left.
Okay.
No. That's okay.
Right.
Let's do top right.
Okay. How many buses go from the town centre to the car park between 8 and 10? Between 8 and 10 o'clock. So town centre to It's weird, but the ones that are within the hour of 8, it's only from 8 or 8:15 or 8:35 to 8:47.
Well, how many between? Let's say 8 to 9 or something.
8 to 9. So none. It's only from 9 to 9:14, 9:20 to 9:32. Or am I going mad?
So the first one is at 8:03.
Yeah.
So that's between 8 and 9.
8 and 3. Isn't it from 8:09 to 8:15?
8:03 to 8:15 at the car park.
So from the town centre to the car park.
Yeah.
Oh, no. Yeah. So that's not from 8 till 10 o'clock. 8 till 10.
So
Let's say
like 8:03 is between 8 and 10.
8:03.
So what other buses leave the town centre before 10?
Before 10. Oh, so 8:35. 9:02, 9:20.
Okay, and then every 15 minutes. And so will there be any more?
So 15 minutes from 9:20 would be 35, 9:35. And then 9:55.
So I believe it'll be 50.
Oh, 50. That'll be the last one then, because another 15 on top of that would be 5 past.
And so how many buses is that?
So that's 6 buses.
Yeah.
I don't know why that confused me so much, but I was looking from sort of 8:03 to 8:15, 8:35 to 8.
Okay. Yeah, you're kind of looking at the thing. Okay, how about top left?
Okay, let's get for his one. Then he's going to drive from home. He has to ferry his 3/4 of an hour before the ferry leaves at 7:30. It's 3/4 of an hour before the ferry leaves. 3/4 of an hour. So that's an hour before it leaves would be 12:30. Quarters of an hour before would be 12:45. So it will take Kevin an hour if he has to drive to get to Grace. What time should he leave home? So it's going to take him an hour and 50. So an hour and 50 minutes before 12:45. So 2 hours before would be 10:45. 10:45. 10:55.
Yeah. Yes, that's it. Okay, I think you're good for those. I think you'll be fine for those. Okay, how do we do top left?
Top left. Okay. God, I've not studied this yet. Actually, I've not looked at this properly. Measure the bearing, Steve. Stevenage. God, I've completely forgotten this. You just
So you
join the points.
Yeah, Stevenage to Langford. And then how do you do a bearing? Well, so it's going to be, so you point north.
Yeah.
Turn clockwise and stop when you hit the line. So let's say that's north and that's north. But which angle of them do we need?
So we go So it's from Stevenage. So we start at Stevenage and go all the way.
It is not from Stevenage. It is of Stevenage from Langford.
All right. So it's from Langford. So from Langford.
And so which angle is that?
So it's 360.
Like top one, bottom one?
So the top one.
From Langford to Stevenage, yes. And so it's that angle there.
Right.
And so you measure that with your protractor. Put zero. Put the cross on that cross. Put 0 at the top, and then just do it. Middle one.
Okay. Bench from the fountain. So it's from the fountain. So you sort of draw a line up north from the fountain.
Okay.
And then with your protractor, you would sort of from the point of 0 pointing up, you draw the line first between fountain and bench.
Yes.
Then you move it along. You measure along your protractor until it meets the line.
Of the bench from the fountain, and so it's from the fountain to the bench. There we go, and it's that angle there.
Is this Lokian construction? Is that what this is?
It's in the same topic.
Right. Okay.
But yeah. So this is kind of part of it. Any idea how you do top left?
Top left. Okay. 2 villages. Village A. It's on a bearing of 38 degrees from Beckhampton. So that measures 38 degrees, and A is 6 centimeters. A is 6 centimeters from B. Hold on, the village Avebury is on a bearing of 8 degrees from Beckhampton. Avebury.
So it's on a bearing of 38 degrees from Beckton.
Yeah.
So Beckton, that's put our cross on their X.
Yeah.
Point 0 to north. And we find 38 degrees.
Right.
So 38 degrees, there's 40.
Yeah.
So it's there. So we move that. So we know it's somewhere along there.
Right.
So it's on that bearing.
Yeah.
And then it says A is 6 centimeters from B. So what would you do with your ruler?
6 centimeters from B. So A is.
So we have to draw where A is.
Right. So A is along the line, the end of that line, the red line. Is that what A is?
Well, it's 6 centimeters away from B, so it's somewhere on the red line.
Right. Oh, so you just measure 6 centimeters along the line.
Yes, I accidentally did millimeters. But yes, so you can see there, that's 60.
Right.
And so it's just there, and that's where we make our X. Yeah, so if it's on a bearing, so it's at that angle.
Right.
And bearings are always point north, turn clockwise, stop on the line, and they're always 3 significant figures, so 0, 380, sorry, 0, 38.
Yeah.
And so we put our X there.
Right. Okay.
How about this one down here?
Okay, scale. So represents 2 kilometers. School part is due north of the church. The school is 15 kilometers due north of the church. Of the church. 15 kilometers of the church. So 15. So 1 centimeter is 2.5. So 15. So it'd be 15 divided by 2.5.
Yeah. 2.5, and that's the same as 30 over 5 if you double both of them.
Okay, so so they're both in the 5 times table. So 6 over 1.
Yep. And what's 6 divided by 1?
It's just 6.
Yep.
So basically it's 6 centimeters. So on the total mark position of the school. So the school is 15 kilometers due north from the church. So from the church, you measure 6 centimeters along.
Yes. And which direction?
North.
Yes. So just straight up. So
Straight.
just go 6 centimeters up and
Right.
make an X and label it with an S.
Right.
And you do that. Yeah. Any questions there?
And yeah, it makes sense.
So these are part of constructions.
Right. What marks do these carry? Are these 2 markers?
These are all 2 markers.
Markers, okay.
Yeah. Okay, top left, how do we do this?
Okay, construct an equilateral of equal sides 6. So 6 centimeters. So so we know that the base is a different length. The sides are going to be the same length. So actually no, they're all going to be the same. It's equilateral. So yeah, the base is 6 centimeters long, and then you draw a line up the middle.
No.
No, that's if it's an isosceles.
Yeah.
So 6 centimeters long, and then from 1.6 centimeters up, and then 6 centimeters, and you just join it.
So that's 6 centimeters. There's a special way to do 6 centimeters. The way you would do it is you take your protractor.
Right.
Do I have? No. Sorry, a pair of compasses.
Oh, right.
And you set it to 6 centimeters. So you put your point here.
Yeah.
And you do like an arc like that. So all those are 6 centimeters distance.
Right.
Put the point there. Something like that. And then you do like all of these are 6 centimeters.
Right.
And then where they cross over is where it's 6 centimeters for both of them.
I see.
Something like that.
Okay.
Not easy. Something like that.
Great.
And then that would be, you would know that it's 6 centimeters. Well, it's the
Right.
best I can do.
Makes sense.
So how would you do this one on the right?
Okay, space below. Use the ruler and compass to construction sides 8 centimeters. So, like you said, use a compass. Well, first of all, you would draw a line 8 centimeters along for the base. And
So
then,
they provided one.
I've already done that. Okay, so you have the pencil and the compass in between. You measure it as it's not using a. Is it a protractor? No,
Yeah, it's a pair of compasses.
it's a pair of compasses, right? So yeah, just ensure that the gap is 8 centimeters.
Yeah, so you'd use your ruler to make it 8 centimeters.
Yeah, and then you get 1 point and rotate it.
Yeah, so you put that there, and it's like something like that. Yeah. Put the point there, and it's going to be like other side, and then you would join them up.
So basically, where it intersects, that's your point. Basically.
Yeah, because that point is 8 centimeters from both.
Right.
So where they cross over, and you don't rub anything out. That's your working out.
Oh, I see. Okay.
So that point is where they cross over. So every, like if you've done it, because if you think about it, if you did it all the way around, it would be a circle of radius 8.
Of course.
And so every point is 8 centimeters away from here. And then with the other one, every point on the circumference is 8 centimeters from here. And so where they cross over is the one point where they're both 8 centimeters away.
Got you. Right.
And so all 3 sides are equal, although you don't need that.
Yeah.
Okay, how about top left?
Lines of symmetry in the rectangle. So would just be through the middle.
What way?
Going down.
Yeah.
And down and across.
Yes, so there's actually 2. How about top right?
Same as a rectangle. Down through the middle and across.
Yeah. How about bottom left?
Bottom left. So that would be 1 through the middle going down, another through the middle going across, and then a diagonal one going down, and then another diagonal one going down.
So this one has 4, is it?
Yeah.
Yeah, I believe so.
Yeah.
Well done. And there it is there. Top left.
So I'll draw the lines of symmetry. So it's just going to be one line going down the middle, a line going across the middle, and a line going down diagonally.
Yeah.
And then likewise for the other side.
Yeah. Top right.
So that would be 1 down the middle.
Yeah. It's equilateral.
Yeah. So a diagonal one.
Yeah.
Going through. And then another diagonal one going along.
Yes, and that's because all the sides are the same length. So a square has 4 equal sides, and so that has 4 lines of symmetry. Equilateral triangle, all 3 sides are equal, and so that has 3 lines of symmetry.
Right.
All right, let's try this.
Okay. shade as few squares as possible. So the dotted line. As few lines as possible. As few squares as possible. So so you would do. So you'd shade the one on the far left, 2 up from the bottom. That.
Far left. This one?
Yeah.
Okay.
And then in the middle, like to the right of the dotted line, at the top.
This one?
Yeah, that one.
Okay.
And then at the bottom as well, to the left. That one.
Yeah.
Is that it? Is that correct?
Well, here, let's say the top. You have to make it symmetrical. So we have a white here, but no white here.
Oh, okay. Oh, so that would be, you just fill in the gap at the left, that one.
So are there any other like that?
So yeah, the bottom right, to the right.
Mm-hmm.
And then at the top, the second from that one, yeah.
That's it.
Right.
And so you've got that ring going around.
Right.
That's it. How would you do top left one?
So it's basically a square along to the right of the line.
Yeah. So
just match it.
Yeah, and this is what 2 markers look like.
Right.
And you're fine there.
Great.
How about this one?
Okay, reflect the shaded triangle in the y-axis. So that's so 2 squares along, like where it says 2, like y2.
Okay.
2 along.
From here, is it?
Yeah, from there, and then.
That's fine. Yeah. So the important thing is that you know the y-axis from the x-axis.
Yeah.
I think you're fine for there. Did we do diagonal?
I think so.
Yeah.
Yeah, we did. Yeah, I mean it would be. Yeah.
Okay. How about this one?
Okay. Describe fully the single transformation from A to B. So it's a reflection.
Mm-hmm.
And it's what's the other thing? It's like a movement. But there's a word for it, like a.
No. So you just have to say what it's reflected in. Like what's the.
Reflected in the y-axis.
Correct. Top left.
Okay, on the grid, rotate 90 degrees clockwise about the point 0 or 0. So 90 degrees. Rotate the triangle clockwise. So 90 degrees is going to be, it's half of 180, so it's like the triangle will end up upside down underneath.
So 90 degrees is a quarter of a turn.
Quarter turn, right?
So let's say that's 2, that's 3. And so if you turn it a quarter of the way clockwise, the 2 is now here.
Right.
And the 3 is now on top. I don't know if that's what you were referring to.
I did it. I had it. I answered it wrong in my head.
So clockwise that way, and it's 90 degrees, so a quarter of a turn.
Right.
Okay, how about this one?
So, say the point, it would move sort of down. It's like the triangle would be facing completely down. Like the point will be facing down through the middle.
Yeah. So let's see. So that's 2 diagonals. Then you have the base is 3. And then you just join up that. Yeah. And you can get tracing paper and just trace a turn as well.
Right.
So that is the 2 markers of all geometry. Let me just take a look. Yeah. I think we're okay there. Those are all. So how do we do top right one?
Okay, measurement catering from Skelton. So first of all, you join the points from Skelton to Catalan. From Skelton. So you get your protractor, the point 0 on the north line. Measure it down until it hits the line.
Yeah.
And then it's 3 significant figures.
Well done. You're okay for that? Yes, I think okay. All the lines of symmetry are gonna be fine. Reflection's fine. That one's fine. That one's fine. And so, yeah, I think so the only stuff now is the 2 mark data, and then I'll be happy. So I've got the 2 mark data here. It says a lot of it, but there's probably a lot of duplication as well. How was that for you, Pierre?
Yeah, it wasn't too bad. It was my first time looking at Loki in construction. I haven't had a chance to look at it yet, but I think once I look at the revision videos, and it'll be fun.
The videos are quite good because
yeah.
Sure. Any questions for me in general?
So what are we gonna be covering tomorrow?
So tomorrow we'll start foundation. We'll start data 2 markers.
Data 2 markers, great.
And I'll put it in the email. I have it mostly ready here.
Yeah, brilliant, great.
Any other questions?
What time is the class tomorrow again? Is it